Multithreading is a process where you can have multiple things happening at the same time. When you set up multithreading, you are implementing what Java calls concurrency, concurrent operations that can execute simultaneously. When you run code within a single class, for example in the main class, only one thing can be executed at a time. But if you want to do several tasks at the same time, you need to create a threads. In order to create multiple threads, you can either create your new classes that extend a class called thread, or you can implement an interface which called runnable. In this example we will see how to create a thread using extend of class. We will create project called extend thread. We will create a new class myThread. I'll go to my package, right-click and choose new class. I'll name the custom class myThread, and I'll set its superclass as the thread class. Notice that the thread class is a member of the java.lang package, and so you won't need a special import statement for it. I won't add a main method because this thread class won't be executed on its own. Instead it will always be called from a main application. And I'll click finish. My custom class is extending thread as its superclass, and the one method that I have to implement in my custom class is a method called run. The run method returns void, and it will be called automatically whenever I want to start my new thread. I will place the cursor inside the class definition, and I will press Ctrl+space to see a list of all the methods of the superclass. Within the thread, I will create a loop. I'll set an integer variable to indicate how many times I'm going to do a loop. I will name the variable iterations, and I'll set it to a value of 4. Next I'll create a for loop. Within the for loop, I will output thread unique number and the current iteration. In order to print current thread unique number, I will use static property of the thread class, which called current thread. This will give me the current thread object, and the current thread object has a method getID. It will give the ID of the thread. I will output the string created, and then after I do the output, I'll pause execution of the thread for 3 seconds. To do this, I'll call a method called sleep. This is a static method of the thread class. Because I'm executing the code within a class that extends thread, I don't need any prefix. I can just call the method directly. When you call sleep, set the pause in milliseconds. So if I say sleep for 3000, that means I want to sleep for 3 seconds. Notice that causes a compiler exception. I moved the cursor over the error indicator, and I see that I have an unhandled exception called Interruptedexception. An Interruptedexception is thrown whenever the thread is interrupted, and you can interrupt the thread from outside the thread. That is from a process that instantiates and starts the thread. Whenever you call the sleep method, you have to handle the interrupted exception. Now I will surround just that call with the try, catch block, so that if an exception happens, I'll jump out of the for loop automatically. So I select the sleep statement, then I will right-click, and I'll choose surround with try, catch block. Eclipse automatically detects the interrupted exception that might be thrown, and so it sets up a catch block with that exception class. I will print the error to the console using following statement and passing the exception object. At the end I will write end of program. Again, the most important thing here is that I'm implementing the run method. That's the method that's going to be called when I'm starting a new thread. Now I'll go back to my main class. Within the main class I'm going to do another loop, so I will create another integer variable which I will call main iterations, and I'll set its value to 5. Now I'll create an instance of my custom thread class. I will set the data type myThread, and I will call it myThread, and I will instantiate it with the automatic constructor. Next, I'll start the thread. Because my custom class extends the superclass thread, that means I have access to all of its methods. And the most important message here is start. When you call start from the primary process, that results in calling the run method in the custom class. Now I'll create my own loop and do a little bit of output from the main process, so I can see that both processes are running at the same time. I will print similar output. I will create a loop, and within the loop, I'll do a little bit of system output, and I will output from main process and the thread unique number. Then, just like I did in the thread itself, I'll add a call to the sleep method. This time I have to call the sleep method explicitly as a static method of the thread class. I didn't have to do that in the custom thread class because I was already in a class that extended thread. But here I will call thread.sleep, and this time I'll sleep for 2 seconds, setting a value of 2000. Then, just as I did before, I'll wrap the for loop inside a try, catch block, right-clicking and choosing surround with try, catch block and add print error to the output. Now I'm ready to test my application. I will run the application, and I immediately see the main process output and then the secondary thread and then the main, then the secondary again, the main again, and the secondary thread. Once both threads complete their executions, the application is done, and it automatically terminates. Notice that the main thread have the unique number 1 but the secondary thread have the unique number 11. So in order to summarize it, the simplest approach to multithreading in Java: create your own custom class that extends thread, add your own functionality to the custom run method, and then instantiate the class and start it from your main process. Please click like and subscribe my channel.